So we move on to part 2 of the part 1 of the crypto training for DDC. And here in part 2, we prepare, we get ready for tomorrow. That will be part 2 of the training. Right. Okay. So we have some background, some mathematical tools that we need to understand the more technical encryption tools. The more technical encryption schemes, for those we need some mathematical tools. Right. So the mathematical tools I'll talk about is encoding. I'll talk about bitwise XOR, and I'll talk about modular arithmetic. Until now, we translated each letter to a number in the following way. But if we want to truly encrypt messages and make it more secure, we need a way to translate letters to numbers in another way, such that we also include punctuation, spacing, letter case, for example. We saw that, I mean, if you don't encrypt spaces and punctuation and so on, I mean, a lot of the structure of the language shines through. So of course, we also want to encrypt those, right? And we want to translate into numbers. And in particular, we actually want to translate into binary numbers because we want a computer to be able to work with our encryption. Because that's just going to give us a lot more computing power than if we have to do everything by hand. And there's a lot of different ways to translate text into numbers. We'll talk about the one called ASCII, but there's also Unicode and base 64 and others. ASCII is, let's talk about that one. ASCII is convenient. One character is just converted into 1 byte. So 8 zeros or ones. First bit is always 0, so that gives us 2 to the 7, which is 128 possible different characters that we can encode. And this is enough to encode the English alphabet and symbols. And we can just list the entire alphabet, actually. Here it is. So we have the different characters here in green. And then we have the decimal representation if we wanted to encode them into a decimal number. It's often more convenient to encode them, to think about them in hex, because hex is easier to translate to binary. We see that each of the letters is encoded into a hex, and that can of course be converted into binary. Each of the small letters is also, and a lot of different punctuation and spacing and so on. And then we also have some non-printable characters. Might, for example, let the receiver of your message know that now my text has ended or something like that. So note that numbers are encoded into different numbers. So for example, the ASCII character 3 is encoded into the decimal number 51, which in hex is written as 33. And if you want to translate, I just wanted to give some examples for translating into binary. So 33 is of course translated into, so this first represents the first 3, and the second 4 here represents the second 3. A is encoded in the following way, and B and early braces left is encoded in this way. And here you see like the reason why hex is like it's nice to operate with, because binary is a little bit too long to represent, right? Decimal is annoying because decimal, it's not so easy to convert into binary from decimal. In hex, you can just take, I mean, the first part here, that's 7. So the first 4 digits here in the binary represents 7. And the second part here, B, it's 11. So the second part here represents B, represents 11. This is 8 plus 2 plus 1, it's 11. Right. So this is the only time I will, oh no, it's not the only time, but it's one of the few times I'll write binary, because binary is just cumbersome because it's so long. So what do you do if you want to encode a longer text? Like say I want to encode the text, hey, exclamation point. Well, then in hex, I just encode each letter separately, right? So let's see, capital H is 48, small e is 65, small y is 79, exclamation point, where do I have it? Somehow, there we go, exclamation point is 21. So if I want to encode the entire thing, Then I just put the encoding of H, 48, and then this is E, this is Y, and this is the 21, that's the exclamation point. Just put them after each other. And this is, of course, a hexadecimal number, and you can convert that into decimal if you so if you so like. And the same if you want to encode GG, for example, then this is a small letter G, and this is also small letter G, and that can also be converted into decimal if you like. This you can also do in Python, of course. So I just want to show you the code for how to convert characters to numbers in Python. Come on. Yeah, it's my webs test ASCII. Okay. So first, how do you convert a string to? All right, a string to a number. Well, string to integer, right? So if you have a string, then first what you can do is convert it into what's called a bytes object in Python. And a bytes object, well, I mean, that's basically converting your string into a number. Well, into like a into a number that has that's packaged in bytes. That's a number where a number where the length of it written in binary is divisible by 8. Right. So bytes is just like a representation of your string. Let me see. So if I run this. Oh, I need to find. Oops. My file is here. Yeah. Okay. Right. So found a really good explanation of the difference between a string and a bytes object on the internet. So you can Google that if you don't understand my trying to re-explain it. So bytes object, I mean, when you print it, then it will still look like a string, but it will have this B before. And that's because when it's printed, it's easier for humans to read it if they then like take this number and represent it back into characters. But really, the way that this bytes object is stored in Python, the way that Python thinks about it, is as these packages of 8 bits. Right. This is 4 packages of 8 bits that we saw before. Okay. So if you have a bytes object, you can convert it into a hexadecimal number. And then from a hexadecimal number, you can convert it to a decimal number. So here I converted my bytes object into hex, and we see that we get the number that we expected. So let's see. So it was the string hey. So we get the hexadecimal number. Let's see if we can see it here at the same time. We get this as our hexadecimal number, which was exactly the same as I said, right? And what's interesting about hexadecimal numbers in Python is that actually this is a string, because if it was a number, then it would be interpreted as a decimal number. So the way that Python stores hexadecimal, like stores numbers in hexadecimal notation, is it stores it as a string. So if you try to put the type of hex, then it tells you it's actually a string. Right. And then of course you can convert it into a decimal, and then you can print that, and you get the number from the slides before as well. So this is how to go one way, and then if you want to go the other way, if you have an integer and you want to convert it into a string, like let's just take the same integer, the one that we got back before. So let's say we get this number, and then we can convert it to hex, and we can convert it to bytes. and we can convert the byte subject to a string. So let's see this happening. Right. So here we get, so we have this as our decimal, we get back to the same hex. And actually, when we do this conversion from integer to hex, then this is still a string. The hex that we have returned here is still a string, but this function like outputs a 0x and then the number, and that's to let the reader know that this is a hexadecimal number. And it's like I don't know why like this function that outputs a hex number and this function also outputs a hex function, but one of them just outputs the number and the other one outputs 0x and then the number. But in any case, both of them are a string. It's important that, you know, if you have a representation of a hex that starts with a 0x, then you need to remove the 0x before you can convert it into a bytes object. And the way you do that is, of course, this. So you take your hex number, your hex string, and then you just start reading from the second index. So that's cutting off the 0x. When you do that and then convert it into a bytes object, then you get exactly this bytes object. And if you want to, you can convert that into a string. There's a couple of things to know about these functions. Some hex numbers are not printable. So for example, if I have this hex number and I try to print it, so I'm down here, then like say I'm trying to print this number, right? First one, this 18, if I go back and look here, and 18 is, there we go, it's a cancel. And cancel, I mean, the terminal doesn't know how to print that. So what it does instead is just tell you that, you know, here this is character number 18. Then the second character, let me open here, the second character here, that's 30. And 30, let's see, oh, 30 in hex, of course. Here, 30 in hex is 0. So 0, well, that is printable. So then, you know, it will just print 0. 11, again, is not printable. So then the terminal just prints this to let you know this is character number 11. And then the final number, 60, well, that's printable. That's an M. So this is how the bytes object is printed. If it's not a symbol, it knows, like it has a symbol to print. If you convert it into a string, then it will just print the stuff that it knows and just ignore that, oh, there's this non-printable thing in between. So that's one of the differences between string and bytes. Final comment, the bytes function will only accept hex numbers that have an even number of digits. So if you take the hex number 7 and you try to convert that into a bytes object, then it will say non-hexadecimal number. And that's because when you're trying to create a bytes object, then it has to be packages of 8 bits. And this here is only 4 bits. You're only telling it 4 bits. So you need to tell it that the other 4 bits should be 0. So if you do like this, then it will convert this into a bytes object, but it can't print this object. So it just tells you it's a package of length 8 and it represents 7. Okay. So I hope that was fairly clear, a little bit of a walkthrough of how this is represented in Python.